In this video, we're going to talk about piecewise functions. Piecewise functions are just functions that are defined differently in different parts of their domains, as we'll see from this first example. So we want to graph this piecewise function f of x, which is comprised of two cases. For x inputs that are greater than or equal to 0, we use the rule f of x equals 1. But for x inputs that are less than 0, we use the rule f of x is 1 minus x. So the way we compute the output of the function really depends on what input we're putting into the function. Alright, so we want to graph that piecewise function and then compute the values of f of negative 2 and f of 5. First, let's just worry about graphing it though. And actually, before we even worry about graphing the whole piecewise function, let's just worry about graphing the pieces, 1 and 1 minus x. So let's start by graphing 1. Let's just graph the line y equals 1. Of course, that's just a straight horizontal line with slope 0 passing through y-intercept of 1. So there's our intercept, and then we can just draw a nice horizontal line through that. And that looks like this. So there we go. That's the case y equals 1. And the other case is 1 minus x. Okay, so let's graph that also. Y equals 1 minus x. So that also has a y-intercept of 1, but now it's a downward slope. So down 1 over 1. Downward slope, negative 1. We've got 2 points. We'll just connect them up to form that line now. And let's draw that in. So it looks like this. There's our line y equals 1 minus x. Now to graph the piecewise function, we really just need to take pieces of these two graphs and put them together. And these constraints here tell us what piece of each graph we want to take. So first of all, looking at this rule, for y equals 1, we only want to use that rule when x is greater than or equal to 0. So we're only interested in using that rule for the positive side of the x-axis and 0. So we want to take this piece of the graph over here that lies above that positive side of the x-axis and 0, and we'll use that in our piecewise function graph. So let's go ahead and draw that in. There's of course at 0, the y-intercept is 1, and then we just want the piece of the graph that's to the right of that. So we'll just draw that horizontal line for the right. Okay, then for the other case, 1 minus x, we only want to use that rule when x is less than 0, when x is negative. So we'll look to this graph here, y equals 1 minus x, and we just want to take the piece of that graph that is over the negative x-axis, so over that place. Okay, so let's go ahead and indicate that. So we're taking this piece over here, and that's what we're going to move into our graph. So that takes off from the same place, that y-intercept of 1, and then let's get another point. Maybe go over 1, up 1 in the negative direction, so over 1, up 1 in the negative direction. There's a point that we can use to connect and draw a line, and here we go. Draw that in, and there it is. Perfect. So there is a nice graph of y equals f of x, our piecewise function. Now let's move on and compute the values f of negative 2 and f of 5. First, let's just do f of negative 2. So f of negative 2. In order to know which rule we use, we have to take a look at the negative 2 and see which constraint that satisfies. Negative 2 is of course less than 0, so that satisfies this constraint, so we'll use this rule, 1 minus x. So f of negative 2, using the 1 minus x rule, that just becomes 1 minus negative 2, which simplifies. That's just 1 plus 2, negatives cancel, and that comes out to 3. So f of negative 2 equals 3. We can also check that in our graph. If we go back to negative 2, this is negative 1, negative 2, and where does the function go for x is negative 2? Well, it's right over here, and that's at this y-coordinate. There's 1, and then there's 2, and then there's 3. Great, so that makes sense with our graph as well. Now let's do f of 5. So I want to compute f of 5, and we take a look. For x equals 5, what rule do we use? Well, 5 is clearly greater than or equal to 0, so we need to use this rule here. For x greater than or equal to 0, the function rule is just output 1. So f of 5 is just equal to 1. Graphically, that makes sense too, because anywhere on the positive x-axis, the function is just a horizontal line at 1. so its value never changes here. So no matter how far we go, the function value for any positive number will always be 1. So there we go, makes sense. Alright, so now we know how to graph a piecewise function, but now let's do the other way. Let's start with a graph and then come up with the formula for the piecewise function. So that's what we want to do here. Write the formula for the piecewise function whose graph is shown below. Alright, so let's think about these two pieces separately. Let's just get the equations of these two pieces separately and then we can think about how to put them together. But so, starting with this left piece maybe, what is the equation of, if we were to continue this as a line, what would the equation of that line be? Well, we see that it has an intercept at 2, y-intercept at 2, and what's the slope? Well, slope is up 2 over 1, so 2. Okay, so that makes it pretty straightforward to write this equation. That's y equals 2x plus 2. Okay, so now let's think about the other segment here. Same idea, if we were to continue this as a line, what would its equation be? So let's take a look. Y-intercept isn't so clear here, but can we get the slope? The slope is down 2, and then over 1, 2, 3, 4. Let's write that over here. So slope is negative 2 over 4, which reduces to negative a half. And then what about the y-intercept? Well, we can go ahead and set up an equation and solve. So let's use y equals negative a half x plus b, and let's pick out a point on that line that we can plug in and solve for b. So let's see. The clearest point maybe is 1, 2, 3, 4, 5. When x is 5, y is 0. So we'll take that point 5, 0, and we'll plug it in here. Y is 0, and then x is 5, so negative a half times 5 plus b, so 0 equals negative 5 halves plus b. Add 5 halves to both sides, and we get 5 halves is equal to b. Okay, so that gives us our line. Our line is just y equals negative a half x plus 5 halves. Okay, so let's start writing down our piecewise function. We'll have f of x is equal to two cases, one for each piece. One of the cases will be this piece on the right side, the negative a half x plus 5 halves, and then the other case will be the piece on the left side, which is 2x plus 2. But we're not done yet. We still have to figure out what parts of the domain correspond to each rule here. Why don't we look at this negative a half x plus 5 halves first? So that corresponds to the x that go from here onwards. So that's all of the x's that are greater than some point. What point is that? That's 1. But it can also be equal to 1 because that's a closed circle. So this is the region x is greater than or equal to 1. So that's what we'll use as our rule here. This rule applies when x is greater than or equal to 1. Now for the other piece of the function, it's going the opposite way. So it's everything from 1 negative, and we don't include 1 because there's an open circle there. So this corresponds to the piece of the domain that x is less than 1. So let's write that in here. X is less than 1. And there we go. There we have it. That is the formula for our piecewise function. Now we know how to translate between graphs and equations of piecewise functions. In the future, we'll continue learning about more types of functions, including inverse functions.